Can you believe it? A single high-speed rail can be longer than an entire football field, weigh nearly 7 tons, and yet be manufactured with millimeter-level precision to withstand hundreds of tons of pressure for decades. Behind the smooth, effortless ride of trains traveling at 350 km/h lies a monumental industrial journey. From blazing furnaces reaching over 1,600 degrees Celsius to gigantic rolling machines, and finally to cutting-edge thermite welding technology. Join us as we explore this incredible engineering process, and don't forget to like and subscribe so you never miss our most fascinating technology documentaries. L'ideo Hitspectrens need special rails. When a high-speed train races along at speeds exceeding 300 km per hour, its entire weight, often hundreds of tons, is continuously transferred onto the rails beneath it. Even the smallest gap, or a joint misaligned by just a few millimeters, can generate powerful impact forces, causing severe vibrations, shortening the lifespan of the infrastructure, and directly compromising the absolute safety of the entire train. That is why conventional railway tracks are simply unable to meet the extreme demands of modern high-speed rail systems. And to create seamless rail lines stretching for kilometers, the journey must begin in a place even hotter than molten volcanic lava. Turning iron ore into molten steel. Deep inside massive steelmaking complexes, the journey of creating high-speed rail tracks begins with a dramatic spectacle unfolding within gigantic furnaces. Thousands of tons of iron ore, coke, and limestone are continuously fed into blast furnaces blazing at temperatures above 1,600 degrees Celsius. Inside, molten metal churns and surges like glowing red lava, while the thunderous roar of machinery shakes the entire facility. Even the slightest error in the mixing ratio can rob an entire batch of steel of the hardness required for high-speed rail applications. And once the molten steel finally reaches perfection, the truly colossal transformation process is ready to begin. Massive casting and recheating operations. After refining, the glowing stream of molten steel begins pouring into enormous casting molds, forming steel billets that stretch for dozens of meters. Amid blinding flames and suffocating heat, each block of metal gradually solidifies like newborn steel emerging from a sea of fire. But this is only the beginning. These multi-ton steel billets are then transferred into reheating furnaces, where they spend hours at temperatures exceeding 1,200 degrees Celsius, softening in preparation for the shaping process that follows. The entire plant trembles under the roar of engines and waves of intense heat, as though a giant steel beast is awakening, preparing to forge rails longer than an entire football field. Transforming steel billet into 120-meter rails. As soon as they leave the reheating furnace, the glowing red-hot billets are fed directly into a colossal rolling system powerful enough to shake the entire factory. A series of steel rollers weighing dozens of tons relentlessly presses, stretches, and compresses the metal with incredible force, causing the steel to lengthen seemingly without end. Within just a few minutes, what was once a rough steel block begins to take on the unmistakable profile of a railway rail, complete with its rounded head and exceptionally thick steel body. Amid the intense heat and deafening clash of metal, rail sections up to 120 meters long emerge for the very first time, marking the birth of these gigantic engineering marvels from a modern industrial production line. Hardening effort strength and durability. Although they have now reached their final shape, these massive rails are still not strong enough to endure the tremendous forces generated by high-speed trains weighing hundreds of tons. Their journey continues through a cooling system, stretching hundreds of meters, where temperatures are controlled with near-perfect precision. Carefully regulated streams of air and water alter the steel's internal microstructure, making the rail head progressively harder than ordinary steel. Even the slightest error in cooling speed can cause an entire rail to crack after years of service. It is here that the glowing steel truly transforms into the durable steel backbone of modern high-speed rail networks. Straightening and cutting with absolute precision. After the demanding hardening process, rails stretching hundreds of meters still have not reached their final level of perfection. A deviation of just a few millimeters can cause severe vibrations throughout an entire high-speed railway operating at speeds above 300 km/h. To prevent this, the rails are fed into a massive straightening system where powerful rollers continuously apply pressure and adjust every centimeter of steel. Meanwhile, an array of laser sensors scans the entire rail with near-perfect accuracy, detecting even the tiniest imperfections. Finally, both ends of the rail are cut into perfectly square profiles, preparing them for an inspection stage even more demanding than anything that came before. The rigorous inspection system. Once perfectly straightened, the gigantic rails enter the most stringent inspection stage of the entire manufacturing process. High-speed cameras, laser scanners, and ultrasonic testing systems continuously examine every section of the steel, searching for flaws too small for the human eye to detect. This multi-layer inspection technology ensures that the rail's internal structure remains perfectly uniform and capable of enduring years of relentless operational stress. As a result, any product showing the slightest sign of abnormality is immediately rejected without exception. Because rigorous quality control is the ultimate guarantee behind safe, smooth, and flawless journeys at speeds of 350 km/h. Transporting the giant steel rails. After passing every demanding inspection, the rail sections, some stretching up to 120 meters in length, finally begin their journey out of the factory. Massive electromagnetic cranes slowly lift tons of dark steel into the air while the echoing clang of metal reverberates throughout the industrial yard. Thanks to highly precise engineering systems, even the slightest movement is carefully controlled to preserve the rail's flawless structure. Viewed from above, the convoy transporting these enormous rails resembles a gigantic ribbon of steel winding its way through the city. The giant rail laying machine. When the ultra-long rail sections arrive at the construction site, a colossal machine stretching hundreds of meters in length begins operation. From a distance, it looks like an entire steel factory crawling along the railway. Inside this remarkable system, a series of hydraulic arms continuously lifts, pulls, and positions rail sections weighing several tons with near-perfect precision. Beneath the track, powerful tamping units compact ballast stones into every gap, creating a foundation strong enough to support high-speed trains traveling at more than 300 kilometers per hour. In just a single day, this machine can accomplish what once required hundreds of workers laboring for weeks. thermite welding for seamless tracks. Once securely positioned along the railway line, the massive rail sections enter the most critical stage of all. Thermite welding, the process that transforms thousands of individual steel segments into a seamless railway stretching for kilometers. A special ceramic mold is placed around the joint, and a mixture of aluminum powder and iron oxide is ignited, producing a violent reaction at temperatures exceeding 2,500 degrees Celsius. Within seconds, a stream of glowing molten steel pours into the mold, fusing the two rail ends into a single solid structure with virtually no visible trace of the joint remaining. When the weld surface is finally ground perfectly smooth, the high-speed railway is truly complete and ready for trains to race across it at incredible speeds. Outro. Final thoughts. Few people realize that behind the railway lines where high-speed trains glide smoothly every day lies an immense industrial journey driven by extreme temperatures, tremendous forces, and near-perfect precision. From iron ore melting in a sea of fire at temperatures above 1,600 degrees Celsius to seamless welds stretching across kilometers of track, every step contributes to creating the durable steel backbone of modern transportation. This achievement is more than a demonstration of powerful machinery. It is a symbol of human ingenuity, engineering excellence, and our ability to master advanced technology. If you found this journey as incredible as we did, don't forget to hit the like button and subscribe to the channel to support us. And right now, on the right side of your screen, awaits the secret behind the machine that powers this entire system. The manufacturing process of the super engines used in high-speed trains. Let's continue the adventure and discover it together right now. Thank you for watching and see you in the next video.